Welcome back. The robotic construction in this video was the result of a need for a simulation of a bird flapping its wings. A first approach was to simply produce a basic wing flapping mechanism. Here is the result, upon which a more detailed approach will follow. But first, let's carefully study a bird flapping its wings. Notice that initially during contraction, each wing consists of two parts, drawn here with red lines. As you see, they form an angle between them. A first approach to construct such a behavior is using two beams and two entangled gears to help unfold them to a nearly linear beam. During a trial and error period and after thoughtful consideration, a rack and pinion gear approach provided the best solution. But as the rack pushed the pinion gear to revolve at a fast pace, a gear ratio of 1:5 was used to bring the revolution speed down to an acceptable pace. Thus, the connected folding-unfolding beams behavior became more natural. And now, the final robotic construction is shown. With the help of a program, it is operating in a continuously variable flapping speed to test the mechanical rigidity and natural behavior. A touch sensor was added as a switch to start bringing the flapping wing speed to a stop. There is also an added bonus of Vulture-like sound. The construction has additional non-operational parts to make the model have a closer likeness to a vulture bird. The program listing is shown at the end of the video. It was made with the EV3 classroom app. Thank you for watching.